Student, now straight away we'll start the second chapter, X-ray. All of us knows the X-ray was first discovered by Röntgen is the professor. He is the first person got the Nobel Prize in Physics in the year 1895. When accidentally while testing the whether cathode ray could passes through the glass, his cathode tube was covered in heavy block paper. So he was surprised when an incandescent green light escaped and projected onto a nearby fluorescent screen. Through experimentation, he found that mystery light would pass through most substance but leave shadow of solid object because he didn't know that ray. That's why called the X, meaning that is unknown rays. This is the X-ray. X-rays are basically electromagnetic radiations which is from radio wave to gamma ray. Under here X-ray it will becomes it having both shorter wavelength and longer wavelength. The shorter wavelength, which is in the order of 0.02 nanometer to 0.14 nanometer. Now X-rays, which is uh, just like uh, the penetrations of into various material depends on density of materials. For example, low density material easily allows X-ray to pass through, while high density material do not easily allows the X-ray. Lead is densest of all metals and X-ray cannot penetrate through it. Hence, the lead is used as a protective cover in X-ray equipment. X-ray can be classified as hard X-ray and soft X-ray depending upon their wavelength. Hard X-rays with shorter wavelength have high penetrating power and are used in metallurgy, while soft X-ray with longer wavelength are used in medical radiography. Before start the X-ray spectra, we will discuss the first X-ray tubes. Now, X-ray tubes are produced high velocity electrons, that is cathode rays, collide with an atom of matter, that is target. It consists of vacuum glass tube, a tungsten filament, and target plate, that is just like molybdenum. Here, this is the filament which is connected for the low tension battery. This is the anode and cathode which is connected for the high tension battery. First, when the load using low tension battery, filament gets heated. The filament, this is the vacuum tubes. Uh, it liberates the electrons. Electrons are having negative charge. This is the positive position. It will attract this and hit to the target, that's the molybdenum. Then X-ray it will be produced. When these high velocity electrons hit the target, the interaction with anode atoms, either with their nuclei or with their electrons, the X-ray it will be released. Now there are two possibilities. When the fast moving electrons interact with the target atoms, there will be some radiation it will be emits. Such a radiations we can denote it as continuous X-ray spectrums. When the fast moving electrons interact with the target of electrons, there you will get the characteristics X-ray. We will discuss one by one. Now students, now take this is the one of the energy level diagrams. Here there is a lower energy state and higher energy state. Here when the electrons it's interact with the lower energy state bombard electrons in one of the shell, that is target atoms. Due to this, the bombarded electrons will knocked out of the shell and bombarding electrons escape in different directions. As electrons knocked out of shell, it creates a vacant energy state. Now, electron in higher energy states, say L shell, which allows a tendency to attain lower energy state, will drop down to K shell, occupy the vacant energy state, thereby replacing the lost electron in K shell. During the transition from higher energy state to lower energy state, it emits a excess energy characteristics wavelength. This is the X-ray. Now student, here there is a two possibility. When the higher energy state like L shell to K shell, such a radiations we can call them K alpha radiations. Sometimes the from M shell electron drop to the K shells, that is called as K beta radiations, like that. Student, now we'll discuss one by one for the characteristics X-ray. Now this is the one of the spectrums. In the as mentioned, depending upon the high velocity electrons with the target nuclei and electrons, continuous and characteristic X-rays are released. Here a typical X-ray spectrum. The spectrum shows radiation in wavelength range from 0.2 nanometer to 1.4 angstroms against the relative intensity. It has both continuous and characteristic radiations. The radiations continuous starting from 0.2 up to 0.5 angstroms and again from 0.7 to 1.4. The wavelength minimum wavelength released spectrum, which depends on the applied voltage to accelerate the electrons. Here there are two spike peaks, that is beta and alpha. These are all the characteristics. We will discuss one by one. Student, when the fast moving cathode electrons interact with the nuclei of target atom, it releases continuous X-ray radiations. The phenomena is based upon purely kinetic energy passed by accelerating electron and on the applied potential between the anode and cathode. This process can be explained with the help of energy relations in the previous slide already knows. There are two states. These are the continuous X-rays. Lower energy state and this is for the and excited state. It will be released energy, that is h nu. We can substitute and simplify it. These relations will get it some relations lambda minimum is equal to this much. Now this relations is called as the Dune-Hunt limit relations. Now this is numerical point of is very important. Now we will go to the characteristic X-rays. In the case of characteristic X-rays, already I explained, when fast moving cathode rays directly hit the electron in the target atoms, they knock off the electrons. When the energy transition within the target atom shells causes release of characteristic X-ray. This phenomena is based purely on the atomic shell structure of the target materials. Hence, the release of characteristic X-ray is target material dependent. This process can be explained with help of energy level diagram. Student, suppose in the fast moving electrons, these incoming electrons, when it is interact with the K shells, then from the L shell it will be opening off. In the previous slide I already explained, that is K alpha radiations, K beta radiations. Sometimes suppose the interaction electrons will be escaping from the L shell, there will be a possibilities of transitions of electron from the higher energy state, that is M to L transition takes place. Such a radiations we can denote it as L alpha, L beta, like that. Now this is the way. This is called as the characteristics X-ray. This characteristics X-ray in the metallurgy department is very important. It shows the elemental significance. Now we'll move to the next one is the Mosley's laws. The Mosley was first person to carry out research on the characteristics X-ray spectrum of various target element. Through his work, he established that frequency of K alpha lines, various target element are proportional to their atomic number. He gave the relations between frequency particular spectral line with the atomic number of element of the target materials. According to the relations, Mosley is very important in the periodic table. All of us knows the periodic tables. He is the one of the contributions. Now, student, here Mosley plot the curve square root of frequency versus spectral line, that is the atomic numbers. In the different spectral line he found the things. Here the statement is the frequency of spectral line in X-ray spectrum varies as a square root of atomic number of the element emitting. Mosley's law may be written in this form like this. Here, Z is the atomic number of the element, A and B are the constant depending upon the particular line. Some of the importance of Mosley's laws. According to Mosley's law, it is atomic number, not the atomic weight of the element, which determine the characteristics properties of both physical and chemical. Therefore, atoms must be arranged in a periodic table according to their atomic numbers. Mosley works helped in obtaining perfect periodic table with discovery of new elements. It shows that the properties of element are related to the atomic number and not to the atomic weight. We can use the Mosley law to determine the characteristics wavelength for different element when their atomic number are known. Student, in the next video